Security automation turns repeatable defensive work into a controlled, testable process. It can collect evidence, normalize logs, enrich indicators, review access, validate configuration, open cases, or execute approved containment. Draw the system from left to right. A trigger creates a request. Inputs are parsed and validated. An identity is authenticated and authorized. Policy decides whether the job may continue, requires approval, or must stop. An isolated runner performs a narrow action. Evidence records the inputs, code version, decision, outcome, and recovery path. The key idea is that a script is not merely a shortcut. If it can disable an account, change a firewall rule, quarantine a host, rotate a credential, or delete data, it is part of the security control plane. Treat it like production software. Begin with a human procedure that is stable, frequent, and measurable. Define success, failure, ownership, time limits, and a safe manual fallback. Automate one bounded step before connecting the entire workflow. Good automation reduces toil while preserving judgment at important decision points. It should fail safely, use the least privilege possible, avoid exposing secrets, emit useful telemetry, and support rollback. Fast execution without those properties only makes mistakes travel faster. Python, Bash, and PowerShell overlap, but they have different centers of gravity. Use Python when the task needs structured data, APIs, reusable modules, cross-platform behavior, testing, or non-trivial control flow. Python is a strong choice for parsing JSON, CSV, network ranges, audit exports, and event streams, correlating records, calling security platforms, and building maintainable command line tools. Use Bash when the task is small, local to Unix-like systems, and mostly composes existing commands. It is excellent for wiring together trusted utilities, checking services, collecting files, managing a short pipeline, or preparing artifacts. As data structures and error paths grow, move the logic into a language that represents them directly. Use PowerShell when administering Windows, Microsoft services, directories, cloud resources, or any system with object-oriented cmdlets. PowerShell passes structured objects through the pipeline, which avoids much fragile text parsing. Do not choose by habit alone. Ask, where will it run, which team owns it, what data must it handle, which authentication model exists, how will it be tested, and how severe is a wrong action. A 10-line script with broad privilege can be riskier than a large application. Complexity is not measured only in line count. It includes authority, blast radius, dependencies, and recovery. Whiteboard a safe automation plane. On the left are triggers, a scheduled job, a queue message, a detection, a case, or a human request. The trigger carries a schema version, correlation identifier, scope, and requested operation. Validation rejects missing, malformed, oversized, stale, duplicated, or out-of-scope input. Policy then evaluates requester identity, workload identity, target environment, risk, maintenance window, and required approval. The runner is isolated, ephemeral where practical, patched, and minimally provisioned. It receives a short-lived credential scoped to the exact API, resource, and action. Network egress is restricted to required destinations. The runner retrieves approved code by immutable version and verifies integrity before execution. Separate planning from applying. The planning phase calculates intended changes and presents a diff. Low-risk read operations may proceed automatically. High-impact actions, account disablement, network blocking, credential rotation, mass remediation, or deletion should require explicit policy and often independent approval. Store secrets in a managed vault or workload identity system, never in source, command history, arguments visible to process listings, logs, or temporary files. Redact sensitive fields from telemetry. Finally, write an append-only audit record, who or what requested the job, the validated scope, code and configuration versions, approval, actions attempted, results, errors, and rollback status. In Python, prefer a library API over launching an operating system command. Use pathlib for paths, JSON and CSV for structured files, ipaddress for networks, hashlib for supported hashing tasks, and well-maintained service SDKs for authenticated APIs. If a subprocess is necessary, pass the executable and each argument as a list. Avoid constructing one command string from external input, and avoid shell equals true unless there is a specific, reviewed reason. Python's official subprocess documentation directs developers to read the security considerations before using a shell. Validate at the boundary. Parse input into an explicit schema. Enforce allowed operations, identifier formats, path routes, network ranges, record counts, time windows, and payload size. Resolve paths before use and reject traversal outside the authorized directory. Treat API responses and files as untrusted even when they come from internal systems. Use timeouts for network and process calls. Check status codes and exit codes. Bound retries with backoff and jitter. Make state-changing functions idempotent, or attach an operation identifier so a retry cannot repeat a destructive action. Keep configuration separate from code and secrets separate from both. Pin dependencies, scan them, use isolated environments, review transitive packages, and lock versions for production jobs. Write unit tests for parsing and policy, integration tests against a sandbox, and negative tests for malformed input, authorization failure, partial results, timeouts, and duplicate execution. Emit structured logs with correlation identifiers and action summaries, but never tokens, passwords, private keys, or sensitive payloads. Bash is concise because the shell performs expansion, splitting, globbing, redirection, and command lookup for you. Those conveniences become hazards when data is mistaken for syntax. Quote variable expansions unless you intentionally need splitting. Use arrays to preserve argument boundaries. Place a double dash before operands when the command supports it, so a value beginning with a dash is not treated as an option. Never let external input choose the executable. Avoid eval and avoid concatenating untrusted values into a command line. Use an explicit interpreter line and a controlled path. Resolve required commands before the job starts. Do not trust the current directory for executables. Set a restrictive mask when writing sensitive artifacts. Options such as noun set and pipe fail can expose mistakes, but do not assume a single strict mode line makes a script safe. Bash error behavior has exceptions, especially around conditionals, pipelines, functions, and command substitution. Check critical return codes deliberately and test the actual failure paths. Create temporary working directories with a secure utility, record the exact path, and clean them through a trap. Quote the cleanup target and reject empty or unexpected paths. Avoid broad recursive deletion, unresolved variables, and globs in destructive operations. Use shellcheck or an equivalent static analyzer, format consistently, and keep bash jobs small. When the script starts parsing complex JSON, maintaining nested state, or implementing a policy engine, bash has stopped being glue. Move that logic to Python or another language with explicit data structures and tests. PowerShell is strongest when you keep objects as objects. Filter and select properties directly instead of formatting output and reparsing text. Export structured results only at system boundaries. Define advanced functions with typed parameters, validation attributes, explicit parameter sets, and clear help. Use approved verbs and return predictable objects. For state-changing commands, support should process so operators can use WhatIf and confirm to preview scope. Make errors actionable. Use error action stop where a non-terminating error must halt the workflow, then handle known failures with try, catch, and finally. Do not swallow exceptions or continue with partial state unless the rubbook explicitly supports it. Attach correlation identifiers and target information without leaking secrets. Use managed identity, certificates, integrated authentication, or a supported secret vault instead of embedding passwords. Microsoft's current guidance discourages secure string for new development as a general password solution and recommends stronger authentication approaches. Script signing can establish publisher and integrity expectations. Application control for business and constrained language behavior can provide stronger platform enforcement. Execution policy helps prevent accidental script execution, but Microsoft explicitly describes it as a safety feature and defense in depth, not a security boundary. Enable appropriate PowerShell logging, centralize it, and protect access and retention. Review module sources and versions before importing them. Test scripts with Pester or comparable tooling, including WhatIf output, permission denial, remote failure, duplicate input, and rollback. Start security automation with read-only, evidence-producing workflows. A log triage job can collect bounded records, normalize timestamps and identities, enrich addresses and hashes from approved sources, group related events by correlation identifier, and produce a case-ready summary. Preserve the original evidence and record every transformation. An indicator enrichment job can validate format, deduplicate input, check allow lists, query trusted intelligence within rate limits, score confidence, and separate facts from analyst judgment. Do not automatically block an address or hash merely because one external source labels it suspicious. An access review job can inventory identities, roles, last use, ownership, and privilege, compare them with approved policy, and open review items. Removal should require an owner, scope confirmation, and a recovery path. Configuration compliance scripts can compare actual settings with a version baseline and propose a diff. Remediation should be idempotent, tested in a canary group, and bounded by stop conditions. Incident response automation may isolate a host, disable an account, revoke a session, rotate a credential, or block an indicator. Those actions need stronger authorization, verified target identity, concurrency limits, approvals based on impact, and a tested restoration path. Keep collection, enrichment, scoring, decision, and action as separate components. That separation lets teams improve logic, substitute data sources, review decisions, and test dangerous actions without running them. Production automation must expect partial failure. An API can time out after applying a change. A queue can deliver the same message twice. A job can lose its luck. One target can succeed while the next fails. Use idempotency keys, state checks, leases with expiry, bounded concurrency, and explicit checkpoints. Distinguish safe retries from actions that require reconciliation. Never retry destructive work blindly. Provide a dry run mode that calculates the intended scope and changes without applying them. Test in a sandbox, then a canary set, then expand gradually. Define maximum targets, maximum changes, maximum data volume, time budgets, and failure thresholds. Stop automatically when observed impact exceeds the plan. Version code, configuration, schemas, and runbooks together. Require review and protected branches. Sign or otherwise verify released automation. Pin the runtime and dependencies. Scan source and packages, but also review the automation's authority and business logic. Monitor job success, failure, duration, skip targets, retry count, approval latency, rate limit behavior, drift, and rollback. Alert on unusual scope, new destinations, privilege changes, disabled controls, and repeated policy denials. Every production automation needs an owner, support path, maintenance schedule, decommission criteria, and manual fallback. Practice disabling the job, revoking its identity, restoring changed state, and reconstructing what happened from logs. Measure analyst time saved, response consistency, error rate, time to containment, and recovery quality, not simply how many times a script ran. Finish with the checklist. 1. Select a stable, bounded workflow with an owner, success measure, manual fallback, and explicit non-goals. 2. Choose Python, Bash, or PowerShell based on platform, data, integration, testability, and team ownership. 3. Validate every external input, target, path, identifier, count, time range, and destination. 4. Use a dedicated workload identity with short-lived credentials and the least privilege required. 5. Prefer structured APIs and objects. Avoid shell command strings, eval, fragile text parsing, and secrets in arguments or logs. 6. Separate plan, approval, execution, evidence, and rollback. 7. Make changes previewable, idempotent where possible, bounded by rate, scope, concurrency, and time, and protected by canaries and stop conditions. 8. Test expected behavior, malformed input, denied access, timeout, partial failure, duplication, interruption, and recovery. 9. Version and review code and configuration, pin dependencies, verify releases, centralize sanitized telemetry, and alert on abnormal scope or control failure. 10. Assign operational ownership, practice revocation and restoration, expire exceptions, and measure errors, response quality, and recurrence. Common pitfalls are running everything as administrator, trusting internal input, treating PowerShell execution policy as a boundary, relying on bash strict mode without testing, using Python shell equals true with external data, swallowing errors, auto-blocking weak indicators, logging secrets, retrying destructive actions, and shipping automation with no rollback. This is original CipherVibe educational content. Copyright 2026 CipherVibe. All rights reserved.